Section 3.5, transformation of functions. This one's going to be a little bit different. We're not going to use the book for this section because I feel like I could explain it a little bit easier than the book does. So we'll start off with the actual page that we have here on Canvas. And we could start by going to Desmos. Here we have the toolkit function similar to the way we have in the book, but I'm just going to kind of show you guys how you could play a little bit with this on Desmos. So desmos.com, and it's going to take you right here. So we'll start with the constant function. So the constant function is in the form of f of x is equal to some value c, and c could be any value that you please. So here it's automatically going to be c equals 1. What we have is a constant function that goes all the way to the left, all the way to the right. So our input, any input is always going to give us the exact same output. So again, here it's equal to 1, and it gives us this constant line. In this case, you could scroll out and see that it goes on forever. You could barely see the line because it's kind of going, it looks like it's almost attached to our x-axis. That's just because we're super far away. But no matter how far out we zoom, and clicking on this button, it brings us back to like our little home area. No matter how far out we zoom, we're going forever to negative infinity over here on the left side, positive infinity all over here on the right side, which is what we have for the domain in our, I have it posted on Canvas. So that's our domain. Our range in this case is just going to be C. There's only one value for this, and it's C. So one value for our domain. The next one, again, this one's called our constant function. Let's see if I could. That was our constant function. I'm not sure why it has it like this, but constant function. I think it's just trying to get the trig functions, but this is our constant function. Let's talk about our identity function next. So the identity function is going to be in the form of f of x is equal to x. No matter what input you throw in there, it's always going to throw out the exact same output. So this input is just a line. Our domain, our values of x, let's scroll out. It goes on from negative infinity all the way to positive infinity. It doesn't matter how far out you zoom out. It's always going to be negative infinity in both directions. And the same for our domain, I'm sorry, for our range. It's going to start off going from negative infinity and keep going up to positive infinity as we keep going up. That's identity. And from there, we have our absolute value function. So absolute value function. For this, we're going to do shift // That's going to give us our little absolute value sign. And we put another absolute value sign over here on this end. For this one, we go off to negative infinity to the left side for our domain. For our range, we go off to positive infinity on the right side. But I'm sorry, that's all for the domain, all of our values of x. Let's kind of click over here. For our domain, though, notice that we don't have any values down here below y equals 0. So our range actually starts here at 0 and goes all the way up to infinity. So that's where things kind of change here for our absolute value. And that's kind of all I could say there. It grabs all of the inputs and kind of flips it upside down. So remember what we look like before we put those absolute value signs. We were that line, and we put our absolute value signs after that, and it flips it right back up. So that's pretty cool there too. After that, we talk about our quadratic function. Talk about the quadratic function. So with the quadratic function, kind of start over. Pause really quick. That's going to be our f of x. Quadratic is raising it to the power 2, so equals x raised to the power 2. And let's go back home to kind of see what that looks like. So where the absolute value function looks like a v, this one looks more like a u, but similar properties apply to where this is going to be called our vertex. It's kind of like where we go from decreasing to increasing. Notice that like as we go from left to right here, we're going down in value. And from left to right here, we're going up in value. Same thing with that absolute value sign. Our inputs or our domain is going to be from negative infinity to infinity, because no matter how far out you zoom, you're still going to end up with like values if you do that. You don't really see most of them here because it kind of looks a little funky, but we still have a value that we could plug into the function no matter where we are. It's just that our values end up going really, really high, really, really quickly. But negative infinity and to infinity for our domain, our range is going to start off here from 0 all the way up to positive infinity. So we don't have all real numbers for our range. We're starting off from 0. Notice that we don't have any values down here for the range, but we start seeing values here at 0, goes from 0 all the way up to infinity. After our quadratic function, we have our cubic function. So that's going to be x raised to the power 3. Here we have these values that we could input, even though it doesn't really look like we could input them. We really could. We just have to zoom out far enough. But from here, we are able to input any value that we want. So therefore, our domain is going to be from negative infinity to infinity. Our range this time is also going to be negative infinity to infinity. Doesn't matter what input we put in here. It's always going to give us negatives when we throw negatives in there. It's going to give us positives when we throw positives in there. So for all of this, we end up with those exact same sort of values. And this one, not quadratic, this is going to be called cubic function. So cubic functions. And there we go there. Along with our square root and our cubed root, or I'm sorry, our quadratic functions and our cubic functions, we have square roots and cubed roots. So the way we could input this into Desmos is SQRT for square root. So square root of x, it brings us to this. Remember, we can't have negative numbers inside of a square root because then they become complex numbers, or like they have the imaginaries in there. So here what we're looking at is from 0 all the way to infinity. So only positive numbers. So from 0 to infinity, that's our domain. Those are all the values that we could input. And from 0 to infinity is our range, because our outputs start at 0 and continue on forever. So for both of them, we have 0 to infinity for domain and range. But with the cubed root, so we said SQRT for square root. For cubed root, it's going to be QBRT. So QBRT for cubed root, so cubed root of x. Similarly to x cubed, we're able to input all values and we're able to output all values. Because of that, 3 numbers being multiplied gives us, we do have that property where we have negative numbers. So here we're able to input from negative infinity to positive infinity. And also from there, we are able to output from negative infinity to positive infinity. As we start zooming out, it kind of looks like we don't really have that much of a range, but we do have those values down here. It's just so far off to infinity that we can't see it here. Like we can't see it with our bare eye, but they are there. We are able to have all real numbers for both domain and for range. So this was cubed root, not cubic function. So cubed root for this one. And the last one we're going to talk about is going to be our reciprocal function. So reciprocal, just reciprocating. So whatever we have in the numerator becomes a denominator. Whatever we have in the denominator now becomes the numerator. So reciprocal functions. That's going to be in the form of f of x is equal to 1. And we have our forward slash, so 1 over x. Let's go back home so we can actually see that function. Here, it looks a little cool because we don't have any values here for x equals 0. If you remember with our domain x equals 0, we have an undefined function. So that's the only value that we can't plug in for x. X or the denominator cannot equal 0. So we don't have values here. Similarly, we're not going to have values at 0 for our range. So our range are all real numbers except for 0. The domain is all real numbers except for 0 as well. I hope this helps. And if you have any questions, please feel free to ask. Bye.